let's start then. And today we are going to get more deeply into the topic of innovation. And as I said to you the last time, I would like to have some more interaction with you. I didn't get any questions the last time, but I hope you will be warming up a little bit and ask questions. That's welcome. So, there's no such thing as a stupid question. So, if you have misunderstood something, then maybe it was because it was not so clear. So, what we'll do now is to talk about innovation in different contexts. And you know what we mean by the word innovation? Well, maybe you do, maybe you don't completely. So, in this course, as I said also before, the challenge for you is to develop an understanding, right? It's not about learning mathematical equations or specific solution techniques as such. It is about understanding, and in this case, I can guarantee you that what we are talking about in this class is very important, and it is very important for the future and your own future. This is one I showed the last time. I changed it a little bit. But we talked about the new economy as the driver for why innovation is so important. And as it says here, we are talking about value. And what do we mean by the word value? Do we mean just dollars? Well, it can mean much more. Of course, it depends on the person that you're talking to. For a company, value in decisions may have to do with strategy, for instance. And let's say the monetary rewards will come later. So it's doing the right thing that we are interested in. And the challenge in the new economy is that it's not just about dollars. It's about being able to change, right? Innovation has to do with something new. To innovate means to make something new. And in this course we are particularly talking about new technology, and of course ocean systems technology in particular. So there are many things within a company that has to do with creating a new business opportunities, like changing organization and so on. But of course we will concentrate mainly on technology. Do you know what's understood by all of this? Do you know what the infrastructure for service delivery is? It's very important. If you're going to provide services in your country and maybe all over the world, you have to have an infrastructure, right? So we could talk about a design of the infrastructure. The other things are organizational structure and so on. I guess you understand. But then I added a couple of new points here, which I think during these times that we are living right now are particularly important. And that has to do with energy. So much now depends on energy supply, the cost of energy. The energy cost penetrates into everything that is delivered, right? All the services, all the products are somehow dependent on energy. So the modern society is more than ever dependent on energy. Having enough and having the right kind of energy, having it distributed where you need it. And then we have another thing that all the newspapers are full of these days. It's about climate change, right? Of course, there are two aspects to climate change. I'm not sure how much you thought about this, but there are two aspects to climate change. And one is the human influence on the climate, right? Because that we are going to talk more about it, but it has been generally accepted that there is some influence from all the human activities, all our factories, all our energy production, all our cars and so on, that influence the climate. So the human effect on climate, and then you have the climate effect on humans, right? So that's the second effect. And of course there are also natural variations in climate. So our ability to adapt to a different climate is very important. And personally, I think there's too little talk about how we should deal with climate change as compared with, there's so much talk about the effect of human activity. Of course, we have to be very concerned with that, but we also have to be concerned with how we deal with the climate change, because some of it will come regardless. There's been climate change all the way through history. Okay. So I guess that's enough about climate for this time, but we'll talk more about climate when it comes to ocean systems. And then we, through history, have had some people who have had a lot of insight, understanding. And one is Archimedes. And of course, for people working with the sea and the oceans, Archimedes is very, very important because of Archimedes' law, right? You know Archimedes' law. And like in this case, it's supposed to move. There's a well, anyway, I thought it would be actually activated in this mode. Let me see. No. Okay, but if you have one body with light density and one body with high density, and you lower them into the water, even though they weighs the same in air, when you dip it into water, of course there's an unbalance, and that is because there's less buoyancy on the compact one as compared with the light one. But Archimedes, he invented a lot of things, and he was also a mathematician, as you know. And for instance, the water screw that he invented, and that was before Christ, it's quite amazing. This screw principle is used so much in industry to move different types of mass, like grains and maybe minerals and all sorts of things. So obviously, you know, not just theory, but also being able to translate an understanding into something that would work to the benefit of man. Also, you may have heard that Archimedes was the first to express one of the basic principles in mechanics, and that is moment is arm times force, right? So what he said, that give me a fixed point in space and I'll be able to move the Earth out of its trajectory. That's quite remarkable. He said he could move the whole world if he only had a fixed point and a large lever. Well, of course there are no such fixed point in space. So, but anyway, that was his illustration to make it more dramatic, what he had discovered about these mechanical principles. So typically, you know, the people who really made an impact were people who had, let's say, a theoretical understanding as well as the ability to translate knowledge into something practical. I wonder why I cannot do the simulation here. You know, these are supposed to start moving, but anyway. Another person I would like to mention is this one, Leonardo da Vinci. You know, he was a Renaissance man, and he lived during a time when things were reborn, right? That's what Renaissance mean. It means rebirth. And after things had been very much controlled by the church for many centuries, you know, people became more and more enlightened, and they came up with a lot of ideas. And some of these ideas are remarkable. I'm sure you can borrow books in the library about Leonardo da Vinci, but he had hundreds of innovations and inventions. And he was also an artist, and he was a mathematician, and he was the first person who really did explore the human body by dissection. But some examples: the helicopter. Well, in this case it's not separate wings that gives you a lift, but it's a air screw. Alright? In principle that could work. Well, of course, one difficulty here would be if you turned the thing on top, this lower part is also likely to rotate, right? So he didn't have it quite right, but he touched upon some principles, and of course you can see that it's related to a modern helicopter. By the way, he also did all his writing in the mirror backwards, so he had a so-called left brain, right? And he wrote from right to left, as opposed to what's normal, at least in the West. And also he was thinking about airplanes, and of course learning from nature is one way of getting good ideas. So he was thinking of, like the birds were doing, you know, flapping the wings up and down. Well, of course, that will give you a pretty bumpy ride, but you know, we had the imagination of a flying machine or an airplane. And when we are getting more into our field, you know, he studied hydrodynamics. Think about that. And turbulence. And he even came up with a concept for a double hull ship. And it's not that long ago since, you know, the rules, just a few years ago, the rules were implemented to have a mandatory double hull or double skin for given types of ships, like oil tankers and boat carriers, right? But he was thinking about this. And actually, we can get back to that, but there are some very, very interesting cases in history. Like when it comes to double hull ships, you know, there's a famous English engineer or British engineer by the name Brunel. There's a university named after Brunel. He designed a ship before Titanic. It was called the Great Eastern. It was much faster than the Titanic, and it had a double hull. So, unfortunately, Titanic did not have a double hull, right? But you should not only talk about the West, of course. China, if you Google inventions and China, you'll get so many important inventions that have been done in China. Like, you know, in the West we often talk about Gutenberg as the one who invented printing, but, you know, block printing was done in the Tang Dynasty during the 7th century. Gunpowder was invented before Christ. No, just after Christ, AD. I'm sorry. And 1,000 years later, the Chinese had a rocket weapon. So, well, probably didn't have much influence in those days, but the concept, of course, has proven to be very, very important. The basis for a calculator, 100 AD, and China's Great Canal was built with locks. The name of the person who invented the locks you'll find also in the literature. So, very important invention, right? So one may start to wonder, and I've been so polite as to include some Korean inventions. And for instance, there are not, I didn't find too many listed, but the ones I found to a great extent had to do with the sea, right? Korea is a country with a big coastline and has been attacked through history by many enemies. So, you know, new concepts for ships. The turtle boat is very famous for protecting the people on board. So, obviously, I also read that during the about this period, at the late 1500s, when the Japanese came with a much bigger fleet, they were defeated because the Koreans had better ships. So having the right technical ideas can have a lot of influence and decision, right? So now we are coming closer to our times, and the question is, who invented the shipping container? Anyone who knows? It's not an old invention. Well, it's accredited to one person who realized that some sort of standardization and some sort of framework and packing of goods to be transported was very important. A person who really saw the needs. so, Malcolm P. McLean, a truck driver in the United States. Well, he was more than a truck driver. You know, he had his own company with, I guess, several trucks. So he had probably a little bit larger scope and understanding than most truck drivers. But he designed this box that the container is, and very importantly, you know, he was so strict on if this has to be standardized. He took a patent. He took a patent on the container. He was awarded a patent. And what did he do? Well, of course he could have made money by asking everyone who wanted to use his container to pay a license fee. I mean, that's the most obvious way of making money from an invention, isn't it? To require that one has to pay for using it through a license agreement, right? But he didn't do that. What he did, which was actually smarter, and I would say today too, very often, it's the business model for utilizing, exploiting a good idea may not necessarily be a patent and a license fee. It can be other business models. So he went to the International Standardization Organization and said, you can have a license for my patent at no cost, right? He thereby made it available for everyone to start using his containers. And once it became accepted, you know, the market exploded, because, you know, it was not protected and preventing people from introducing, making containers and shipping, but it was open. And because it was standardized, and he was very strict on that in connection with his license, that no money, but keep the standard. And that was extremely smart. So what he did was to develop a shipping company using containers. And his company, Sealand, became an enormous success. And what do you see today? This was in the 60s and 70s. And what do we see today? Well, the largest container shipper in the world is Maersk, right? The Danish. And they bought up Sealand, right? That's how they became so successful. The biggest container shipping company in the world. So they certainly were based on an idea. And now I hope you are beginning to see how important a good idea can be, right? And in this case, it's not that complicated, is it? You can say anyone could have invented this box, right? To put goods into. I'm sure you could have too, but you haven't. You didn't. Well, of course you were. You are not old enough. But I think it's a good illustration of what a good idea can lead to, right? It has changed the total shipment of goods in the world, right? Nowadays, almost everything is shipped in a container, including fluids. this is quite interesting. If you click on that, and I don't think this works. So, but it's an article from Harvard Business School 5 years back that's written by the dean of the business school and a distinguished professor. And they have written a very interesting paper on Malcolm P. McLean about what they call the truck driver who invented the container business. So it's recommended reading for you. And hopefully it will enhance your understanding. Any questions? Do you think it was very important that it was exactly the dimension that he selected? For the standard TEU, as it's called? Well, yes and no. It was actually quite important too, you know, to fit it on the track, to fit it on a railway car, right? And the concept of being able to stack several on top of each other and locking them together. So, you know, of course, if you change the dimensions a little bit, probably it would have been successful regardless. But one could say that initially he had an idea, then he had also practical experience, right? So he understood what would be good dimensions in terms of length and width and height. So it worked out pretty well. But of course today we have containers that are twice as long. You know, they are double units that can be combined with single units. And we have some containers that are slightly modified also in measures. But in general, you know, the standard TEU is the same as was introduced 40 years ago. So, having this in the back of our minds, what drives innovation? Well, of course, there is not one single answer to that. There may be a certain good idea which may be motivated or unmotivated. And in English, I'm not sure if you have written essays in English, have you? But typically when you write a story in English, you know, about something happening, you use the expression, then a bright idea struck him, right? That's an expression, that's a phrase. But, you know, it indicates that suddenly, you know, one finds a solution to a problem. So that is intentional, maybe, or it can be unintentional. That is motivated and motivated. We can have innovation by accident. I'll give you some examples of that. That's quite intriguing. Then things more or less invent themselves. Just wasn't intended to be a different type of solution, but suddenly there's a solution that is different from what has been available before, and it has value. Of course, personal interests and ambitions, which can be, what could it be? It could be, I want to get rich, right? very few inventors get very rich, but there are some that get incredibly rich. And it could be ambitions. You know, I want to become famous. So for some people, you know, the personal interests are an important driver, but not for everyone. Some people may not care so much about themselves. They are more focused on what the society needs. In one way, that is a better motivation, isn't it? If you can work on problems that are important to the society, and it's not difficult to think about that, is it? Better energy solutions, safer solutions, more environmentally friendly solutions, and of course anything that has to do with health and so on. That's societal needs. To provide clean water to people, right? Sanitary systems. Then of course, which is the big one, that's the market needs. Sometimes one could say that the market doesn't know what it needs, right? And of course, if you have something revolutionary, you cannot expect the market to know that it has that need. But a need can be developed, and of course nowadays we see needs being developed through advertisements, right? Using TV and that sort of thing. That's more dubious, I think. It's, you know, but we always need to do things in a better way, and that's market needs. Then it can be a very decisive decision by, let's say, the management of a company saying, now we want to innovate, because we see that if we are going to succeed, we have to innovate. And we are going to, on Wednesday, start with an example that has to do with the market, and it also has to do with business strategy. And you are going to have a chance to think about it over the weekend. So, but of course, drivers, you know, what is pushing better solutions and improvements is also the fact that we can develop more knowledge through universities, for instance, and not at least research. We get more into that as well. And sometimes, if you really want something to change, well, have a big accident, right? Big accidents are tremendous drivers of change. So that is for good or it's for worse, right? So that's kind of, you pay the price first and then you get the improvement. And of course, wars are also pushing innovation. We'll look a little bit more at that. But very seldom you say it's only personal interest or, you know, just business strategy. Things are working together, and particularly when you are in a company, let's say a large company, and you have a research department, and you have a market department, and you have a production department. All of this have to play together in order to be able to improve, right? But bright ideas, and very often, you know, somebody comes up with a good idea. It may turn out not to be the best, but a good suggestion very often triggers a process where somebody else says, no, that's not like that, you should do it, you should, change this and do it like that. So triggering an innovation process is very important. So it can be by accident, or it can be more a decisive choice that you make to become more innovative. And we'll talk about techniques for becoming more innovative in the company. And this is important because you are going to be key personnel in a company. Probably quite a few of you will be managers, or maybe end up in the university. So it's important that you have a deeper understanding of this process. Very often in academia, people who have been in a university all their lives, they don't really understand the context of research as to improve the situation in society. They think, quite narrowly. But for a good idea to become a real innovation, there's many things that have to happen. Okay, you have to have some fun too, right? Ink drying paper. If you don't have enough glue when you press your paper, or maybe not enough pressure, you get an absorbent paper. So ink drying paper, typical an example of production that didn't turn out to be writing paper, but it turned out to be something useful when you write. And in the old days, of course, writing with ink, it was important to be able to dry the ink with ink drying paper. Bath towels, these loops you have in the bath towels typically. That was a weaving machine that did something wrong initially, and it turned out to be, of course, when you have these loops in the weaving, then you have a much better absorption in your towel. Penicillin by Alexander Fleming, he was working in his lab with bacteria, and he had, unfortunately, turned out to be fortunately, one of his samples got infested with some fungus, right? What is it called in Korean? Fungus? Fungus like mushrooms, but they're this growth fungus. Pardon? Okay. So that got into one of his, test cups, and he saw that, this fungus killed the bacteria. That was not his experiment, right? It turned out to be extremely valuable invention, or should we use the word invention? It was actually discovery, wasn't it? But of course, later on, when you developed, in an industrial context, the ability to make these substances that kill the bacteria, and today we have many different variations of it, then of course this became very, very important. Vulcanized rubber, Charles Goodyear. 3M's Post-it, what happened? 3M is a big company, right? And they wanted to make some sort of glues, and they experimented with different glues, and they found suddenly that they had done something wrong with mixing the glues, so it didn't become a very strong glue, but it became a glue that you could attach to paper, and you could put it on the wall, and it stuck, right? And you could take it off and you can put it back again. So it was a very unusual type of glue. And 3M then saw this opportunity and developed this product, post-it stickers. I'm sure it was protected by patents for some time, but nowadays probably the patent has expired. So it's something that we use almost every day. And 3M is a company that's very much focused on innovation. So if this had happened in a different company, it may not have turned into a product, right? So that shows you something about if you are a manager and something unusual happens in your company, it may turn out to be something very positive, even though it looks like something going wrong, right? So, and we touched upon wars, and there's a quote, a citation that is used very much. Necessity, that is the need for something, is the mother of invention. That is what makes you think of a new, better way of doing things. So it's initially meant on people who have a problem. Let's say you have a piece of equipment that is broken down and you need that equipment, and you think of a smart way of repairing it, right? Because you need it, necessity. So then you may come up with a practical solution. But this is an interesting discussion too that you find at this reference, and that is what we touched upon, inventions and war, right? We had some examples, with the rocket, and we had the example of the warship. And what it says here, well, wars is a situation where new solutions are pushed because you want to be better than your enemy, right? Better in quotation marks. But it turns out that there are relatively few inventions that are created during the war situation, original, including the tanks and radar. They were developed before the war broke up. Radar is very often referred to as a technical device that was invented during the Second World War, but the English had it even before. But of course, when the war came and it became very, very important to discover the German planes that flew over Great Britain, then of course this idea was pushed. So in most cases one can say that wars accelerates a good idea into a real innovation. And one can also have some philosophies regarding if somebody has come up with a very smart weapon that could trigger and start a war. And there's been some discussions about this poison gas that was used during the First World War was partly triggered by the Germans believing that they could easily win a war having that weapon. So, well, this is not really a too nice subject, but it's something that we have to relate to. And so acts of aggression, where something wrong happens, also makes one think about better solutions. So I could have asked you this one before you look at it, but there are so many inventions and innovations that have had a tremendous impact. Have you come across this word before? A paradigm shift? Well, let's say in the West it's become kind of a fashionable word, right? Partly having to do with information technology. A paradigm shift is when the framework or the method changes dramatically in relation to before. So instead of having, let's say, a gradual change, you have a sudden step, right? And what applied before is becoming of less interest, right? And of course, I listed a few examples here. Gunpowder changed the way we perform wars, but it also became very important, of course, in getting minerals out of the mountains, and in many other contexts as well, making roads and so on. The weaving machine, the Industrial Revolution, was really based on mechanical invention. The steam engine by Watt, suddenly one had mechanical devices that could do things much faster than people could do by hand, right? Weaving by hand, and then by turning something, you had an automatic process of weaving, and if you combine the two, right, then you had power to turn a weaving machine. Otherwise you would have to have power from, let's say, a waterfall or something like that. So the steam engine, both stationary and of course later on trains and in many different contexts. The wireless, the ability to send information through the air, wireless telegraph, and then the radio later on. The light bulb, of course, is a classical case. The automobile, the radar, nuclear power, transistor, electronic computer, and DNA, etc., etc. And I'm sure you could think of very, very many things that really have been so important for our society. So I don't think I have to say much more to convince you how important it is to have good ideas, and how important it is to be able to take care of good ideas and develop good ideas into something useful. So typically when people came with the electronic computer, that was the paradigm shift, right? In Sweden, the neighbor country to Norway, there was a company called Facit that was probably the best in the world with mechanical calculators. I'm not sure if you have seen these calculating machines that engineers used in the 50s and the 60s. You could do 10 or 15 digits computations, adding, subtracting, multiplication, division by these mechanical machines that initially were done by hand. And then in Sweden, Facit developed the same kind of mechanical system, but electrical motors driving these calculations. So they were very good at it, but one day, the transistor and the electronic computer came. What do you think happened with that company? Nobody wanted to buy a mechanical calculator, right? So that's another example of a paradigm shift. Okay.